Dear students, welcome to our class on climate change, cloudiness. Earlier we tried to understand climate change, CO2, like that, climate change, methane and nitrous oxide. Now, climate change, cloudiness. Almost all global climate models, GCMs, almost all global climate models predict increased evaporation and precipitation due to surface warming and enhanced long wave radiational cooling from a warmer atmosphere on account of injection of greenhouse gases, GHGs. Now, so what exactly does it mean? Earth and water act as a sink during the daytime for solar radiation, in the night, calm, okay, nights. Long wave radiation is sent back because of greenhouse gases. It is sent back and it is reabsorbed by the earth's surface, which we call it as radiational cooling. Now, here, increased water vapor. Why increased water vapor? From a warmer atmosphere, okay? Warming and enhanced long wave radiation cooling from a warmer atmosphere on account of injection of greenhouse gases. Now, why it is almost all global climate models predict increased evaporation. So, because of increased evaporation, increased water vapor feedback amplifies the direct radiative effect of CO2. So, direct radiative effect of CO2 is amplified. Now, the CO2 absorbs energy in some small segments of thermal infrared segment that water vapor misses, MISSES, that water vapor misses and warms air in a bit more, okay? CO2 warms air a bit more. Now, doubling of CO2, for instance, a case of doubling of CO2 is held to be equivalent to a 13% increase in the water vapor. Now, increased evaporation, 13% increase in the water vapor, CO2, radiation cooling. This is the basis for the remaining part of our discussion. Now, increase in temperature of the atmosphere. Increase in the temperature of the atmosphere enhances the water vapor holding capacity of the atmosphere. This is one point. Another thing is, however, continued increase in water vapor will lead to formation of clouds. Cloud is defined as aggregation of minute droplets of water suspended in the air at higher altitude. So, continued increase in the water vapor will lead to formation of clouds, maybe cirrus, cirrocumulus, pseudostratus, altocumulus, altostratus, stratocumulus, stratus, nimbostratus, or cumulus, whatever it may be, in the formation of clouds, which will reduce radiation received and exert a cooling effect. Again, I would like to enlighten you. Continued increase in the water vapor will lead to formation of clouds, which will reduce radiation received from the sun and exert a cooling effect. Which of these two, first one and second, which of these two processes will eventually dominate, and when and where are difficult to predict? Whether it is momentum transfer, viscal forces, Newton's law of viscosity, or Fick's law of diffusion, or Fourier's law of conduction and thermal, whatever it may be, even fluid dynamics, it is difficult to predict which one of these two processes will dominate. Now, increase in cloudiness. For example, increase in cloudiness, what happens? Increase in cloudiness associated with increase in precipitation naturally in rainy or summer season. In rainy or summer season, particularly in the tropics, if increase in the cloudiness is there, it has a little effect. However, increase in the cloudiness during the winter season, which is not normal, will have a negative effect on the crop. Say, for example, in India, during the rice or wheat or the C3 plants, if cloudiness is there, they are grown during the winter season, they give more yield to us. So, when rice and wheat are giving more yields during the winter season as compared to the southwest monsoon season, if cloudiness prevails, the yields are projected to be reduced. This is what I would like to say. Take home, of course. So doubling of CO2 is expected to lead an increase in the mid and high altitude cloudiness, while thinning of low clouds in the subtropics and mid latitudes with lower albedos due to warming has an indicated, of course, it has got some effect on the radiational cooling. Finally, an increase in CO2 will lead to a reduction in the quantum of outgoing long wave radiation and result in greater cloudiness, with the increase in cloudiness in winter particularly, being double that in the summer and rainy season, which may affect the yields. Thanking you very much.